Okay, so linear speed is equal to the arc length over time. And if you remember from, I was going to say from pre-calc, but you're in pre-calc. Remember arc length, if you're dealing in radians, is equal to theta times radius. So an equation for our linear speed then is v equals theta times r over t, or r times theta over t. Well, our angular speed is defined as theta over t. So we could express our linear speed in terms of our angular speed and our radius. So linear speed is equal to radius times angular speed. Okay, so in an example problem, it says we have a fan, a ceiling fan with 20-inch blades, and we're dealing with a linear speed. The fan spins at a linear speed of 8 feet per second. So question A wants us to find the angular speed in radians per minute. Well, since radius is in inches, first thing we want to do is to convert that to inches. And we know we want to work in minutes, so we're going to want to also convert it to inches per minute. So let's do that first. So 8 feet per second, we're going to minutes, and we're going to inches. So there are 12 inches in 1 foot. There are 60 seconds in 1 minute. So notice seconds cancel, feet cancel or reduce out. So we're left with 60 times 8 times 12, which is 5,760 inches per minute. Now this is equal to our linear speed. So the question wants us to find, part A wants us to find angular speed. So we go back up here, we have our linear speed equals radius times angular. So then angular speed is equal to linear speed divided by radius. Well, linear speed is 5,760 inches per minute, and we are dividing that by 20 inches because that's our radius. So that's the same as multiplying by 1 over 20. And that's going to give us 5,760 divided by 20 radians per minute. And that reduces to 2,088 radians per minute. So the next question wants us to find the number of revolutions per minute. Well, so we want to find revolutions per minute. There are 2 pi radians, so 2 pi radians in 1 revolution. Oops. So we have our angular. We have our angular speed at 288 radians per minute. And we want to convert that to revolutions per minute. And there's 1 revolution, and 2 pi radians is equivalent to 1 revolution. So that gives us, go ahead and do the math. Radians are going to reduce out. We've got 288 divided by 2 pi, which is 45.836 revolutions per minute.